So as I discussed in the last video, solving with graphs is really great for a visual and nice when you have nice whole number solutions. But we want to be careful of that because sometimes it's not easy to see, or maybe graphing just takes too long. So what we need is a way of solving algebraically. And we're going to have two ways of doing that. We're going to have substitution or elimination. So in this video, let's go with solving with substitution, in which we'll follow these steps that I have up here. So first thing we're going to do is solve for one variable, and it could be x or y, doesn't matter which one. You can also use either equation. Lots of freedom here in terms of which variable you're going to solve for. However, something I'm going to emphasize is something that will make it easier is looking for a coefficient of 1. So that'll be our first piece, is solving for one of the variables. And once we have that solution, then what we're going to do is substitute that expression into the other equation. And it's very important to go into the other equation, because if you just substitute back into the same equation, it's going to make it look like there's infinitely many solutions or no solutions, and we don't want that. Okay, then once we're there, we can solve the equation and find the other variable. And just like we did with graphing, we can always check our answer as well. And in fact, I'll even show you how to use Desmos to do a real quick check of your solutions. Okay, so let's try out those steps with this first system of equations. So we have these two equations, and I want to solve for one variable. Something that's nice with this one is that y is already solved for here. We don't need to do anything for that first step. Really, all we need to do is just choose which equation we're going to use. So I'm going to go ahead and use that first equation where I have that y is equal to x plus 1. So we know that that is true. Y is equal to x plus 1. So what I want to do is substitute into the other equation where I know y is equal to x plus 1. I want to substitute into y for the other equation. So in order to do that, what I'll end up with is x plus 1 on one side of the equation equals 2x minus 1. And now we have an equation that's only in terms of x, so we can go through our usual steps of solving. So I'm going to go ahead and subtract x from both sides, add 1 to both sides. So we're going to get 2 equals positive x. So remember our solution. So we're going to have the solution is, and what we're working towards is a coordinate. We need an xy coordinate, and what we just found is the x coordinate. So x is 2. Okay, so we took care of steps 1, 2, and 3. Now with step 4, what we're doing is we're going to back substitute, which means we're going to take x equals 2 and plug it into one of these equations up here, either that y is equal to x plus 1 or y equals 2x minus 1. Doesn't matter which one we use. So let's say we take y equals x plus 1, but instead of writing x, we're going to substitute in the solution we just found, which is 2. So y equals 2 plus 1, which is 3, and that would give us our y coordinate. A good thing to do would always be to check your solution so you know 100% is that in fact right. So algebraically we would have 3 equals 2 plus 1. That's true. We would also have 3 equals 2 times 2 minus 1. So 4 minus 1, which is in fact 3. All good there. Another thing you could do to check your answers if you want to use Desmos, so you could plug into the scientific calculator. Or what we could do is go back to graphing and just graph y equals x plus 1, y equals 2x minus 1, and Desmos nicely highlights that intersection point, and we can see our coordinate 2, 3. So you can use that graph as a quick check of if that is in fact the solution. What we solved, we checked, that is our final answer. Okay, let's look at a more complicated scenario. So what I'm looking for here is I either want to solve for x in one of these equations or y in one of these equations. Now my hint said to look for a coefficient of 1. And again, coefficient is the number that's multiplying with the variable out front. So like these have coefficients of 2, this has a coefficient of 3. this has a coefficient of 1. And my hint is that that makes that value very easy to solve for. So I'm going to do is focus on solving there. So x minus 2y equals 2. And all I'd have to do is add 2y to both sides. So we would have x equals 2y plus 2. Now, just so you know, you can absolutely solve for any of these. Like, let's say we use the 3x plus 2y equals negative 2 to solve for x, so I would subtract 2y. But then I would divide by 3, and everything gets divided by 3, and I would end up with all sorts of fractions, which isn't the end of the world. Everything would still work out. My thing is that if I can avoid fractions, I like to do that. So the trick to avoiding fractions is to look for that coefficient of positive 1. Now, you might not always be able to do that, but if we can, it's a nice step to take. Okay, so x is equal to 2y plus 2. So what I want to do now is go to the other equation and substitute in for x. So we know we have 3 times x plus 2y is equal to negative 2. And we just found that x is exactly equal to 2y plus 2. And I just do a quick double check that I have in fact used both of my equations at this point. First to find an expression for x, and then next to do the actual substitution. But now I have an equation all in terms of y, so I can go ahead and start solving for y. So I'm going to distribute the 3. Combine like terms. 8y plus 6 equals negative 2. Subtract 6 from both sides. Divide by 8. And we just got our y coordinate. So again, I'm working up to the solution is, and we're trying to fill in the blank for a coordinate, and I just found our y coordinate is negative 1. So there's half of the solution. To get the other half, I need to find x, and with that, I'm just going to grab one of my original equations. Doesn't matter which one it is. Let's say I grab x minus 2y equals 2, but now what we're going to do is substitute in negative 1 for y. So x plus 2 is equal to 2. Subtract 2 from both sides. We'll have x equals 0. Again, we could do a quick check. So 0, negative 1. So 0, and then that would be 0 plus 2 is 2. We're good there. 0, negative 1. So we'll just have 2 times negative 1, which is negative 2, is equal to 2. Good there. Or you could go into Desmos, graph them, and see that that's where the intersection point is. Okay, a few more examples here. So, looking to solve for a variable, what I'm seeing is that's already nicely solved for. So, nothing to do there, just x is equal to negative 2y plus 5. And what we're going to do is just pick up that negative 2y plus 5 and put it into the other equation. So I have 5 times x plus 4y is equal to 1. But where I had x, I'm now going to plug in negative 2y plus 5. And let's go ahead and distribute the 5 in. So negative 10y plus 25 plus 4y is equal to 1. So that's a negative 6y plus 25 is equal to 1. Subtract 25 from both sides. Divide by negative 6. And that should be a positive 4. So we have our y coordinates. Let's go, the solution is. And we have an x coordinate, a y coordinate, and we just found our y coordinate. And to find x, let's go ahead back to that x equals negative 2y plus 5, but now we're going to plug in 4 for y. So negative 2 times 4. Plus 5, so x is negative 8 plus 5, which is a -3. So -3, 4. Let's go ahead and check this with the Desmos graphing calculator. Especially with these kind of more complicated, or not complicated, but in the standard form, what's nice about Desmos is you can just type it in whatever form it gives you. So we would have 5x plus 4y is equal to 1. And then we would have x equals -2y plus 5. And we have our coordinate, -3, +4, which is what we got for our solution. Perfect. Okay, one more scenario here with lots of fractions. We can't always avoid fractions, but we'll try when we can. So with this one, I go looking for a coefficient of +1. I'm liking x in that equation to solve for just to make things easier. So x minus y is equal to 14. Add y to both sides. So we're going to have y plus 14. Okay, so we're going to take y plus 14 and plug it in for x in the other equation. Here come the fractions. 1/3 times x plus 1/3 y is equal to 0. Okay, and we will have y plus 14 in the parentheses there. So distributing the 1/3, so we have 1/3 y plus 14/3 plus 1/3 y is equal to 0. And how about at this point we clear out our fractions? We could keep going, but let's just go ahead and multiply everything by the least common denominator, which is 3, and really we're doing that on both sides. So when that 3 distributes, we'll just have 1y plus 14 plus 1y equals 0 times 3, which is 0. That makes things nice and easy. So we have 2y plus 14 equals 0. 2y equals a -14. Divide both sides by 2 for a -7. Okay, so the solution is, and we found our y coordinate first, which is totally fine, as a -7. And then to find x, I'm going to avoid that equation that has the fractions. I'm going to use that x minus y equals 14 and plug in y equals -7. So x minus a -7 equals 14. So x plus 7 is 14, which means subtracting 7 from both sides, x is a +7. And just with all those fractions, I would like to check my answer there. So let's see what we have here. 1/3 x plus 1/3 y is equal to 0. And then we have x minus y is equal to 14. And our answer's all the way out here at 7, -7. Perfect. We checked it. That's our solution. And that's how we do substitution. So solve for one variable, plug it into the other equation, and as you start getting a solution for one of the coordinates, you can go and find the other one. And just please take the time to check your answers, especially when it comes to quizzes or exams, because checking the answer, you'll know with 100% certainty whether or not you have the right solution.